The objective for this lesson is that students will understand decimal number patterns in the place value system through the thousands. In the 4th grade, students learn to identify place value through the hundredths place. Today, they are extending through the thousandths place. The students have learned to identify and model their work with base 10 blocks, wherein the ones place was modeled with a cube, tens with a rod, and hundreds with a flat. In the decimal lessons, students are representing the ones with a hundreds flat in order to envision cutting it into tiny pieces or decimals more easily, and for future use in doing decimal operations. In order to work with decimal number patterns, students will need to understand and use a few vocabulary terms when describing the patterns they see. A decimal is the system of numbers based on 10. It can also refer to the point marking the ones place or a fraction whose denominator is a power of 10 and has a numerator less than its denominator. A tenth is one of the 10 equal parts of a whole and is to the right of the ones place. A hundredth is one of the 100 equal parts of a whole, and its place is just to the right of the tenths place. A thousandth is one of the 1,000 equal parts of a whole, and its place is to the right of the hundredths place. When we learn about decimals, we will use the flat to represent the ones, and when it is cut into 10 equal parts, each of those parts would resemble a rod and represent a tenth of the whole. This can be represented by writing decimal point 1, or 1 over 10, and we see that it takes 10 of them to create the whole. When we divide by 10, we move our decimal to the right once, and if we move to the left, we show that it is multiplied by 10, making the digit 10 times greater. If there are 3 of these tenths, we see that we have decimal point 3. We have 3 out of the 10 pieces it takes to create one whole. We can also apply this to money. A dime is decimal point 1, or 1 over 10 of a dollar. Assuming the dollar to be one whole, we count out 3 tenths. 3 tenths of a dollar is equal to 30 cents and is written as a 30 with a cent sign after it, or a dollar sign with a decimal behind it, and 30. When we have a tenth or a rod, and we want to divide it further by breaking it down into 10 equal pieces, we now have hundredths, represented by the cube. We can see that a hundredth is 10 times smaller than a tenth, as we divide it down and move our digit one place to the right. If we have 6 of these hundredth cubes, then we represent that by writing decimal point 06. Again, we could apply this knowledge to money. If we break a dime down into tenths, each tenth could be represented by a penny. These are each 1/100th of the whole dollar. We could count them out as 6 cents, or 6/100ths of a dollar. Students then extend their learning to acknowledge that when we have a hundredth or a cube, we could still divide this further down to make 10 equal parts of that hundredth. These are called thousandths and are represented again by an even smaller flat. Thousandths are located to the right of the hundredths place and may be written as decimal point 001. It would take 10 thousandths to make a hundredth. It would take 1,000 of these pieces to create just one whole. We don't use thousandths in counting out our money generally, but they are used to represent gasoline prices, taxes, or even in calculating utility bills. Our place value system has the whole numbers and the fractions of a whole separated out by the decimal. If we have 13 and 425 thousandths, we can record this on the place value chart to show that we have 1 10, 3 ones, and 4 tenths, 2 hundredths, 5 thousandths. We know that each place value gets 10 times smaller or is divided by 10 each time we move to the right, and that each place value gets 10 times larger or is multiplied by 10 with each move to the left. The objective for this lesson was to understand decimal number patterns associated with the base 10 place value system through the thousandths. We met this objective by modeling, counting, and recording decimal number places and values.